Let's jump into looking at convex lenses. So this is a special type of lens that we'll talk about here as we go forward. So convex lenses are a type of lens that will focus the light towards inwards, towards a focal point. So they focus the light inwards towards a focal point. You can see that illustrated down here. If you have rays 1, 2, and 3 coming in from the left, as they go through the lens, they get pointed inwards, and you notice that all 3 of those rays intersect at the focal point F here. Now, the reason for that, you'll do a concept development sheet related to this, but basically when it goes in on one side, because the normal line is going to be parallel to, or perpendicular to the surface, it gets bent toward the parallel line when it goes through, and then because the other surface is bent in a different way, when it gets bent away from that parallel line, or that perpendicular line, it gets bent further inwards. So basically, as a result, anything towards the edges get bent inwards, anything towards the center get bent inwards less, and everything focuses on that focal point. So if we're going to sketch the rays for convex lenses, here's the rules that we want to follow. So a ray that is traveling parallel to the axis, it's going to pass through the focal length on the opposite side. So if a ray is coming in a straight line parallel to the axis, so that line that would go through the middle of the lens, then it's going to go through the focal point on the opposite side. A ray traveling through the center of the lens will travel straight and not be bent. So if you're going exactly through the center of the lens, it functionally goes straight through. Now, it is getting bent as it goes into the lens, but then when it comes out the other side, it gets bent a corresponding amount, so it's as if it went straight through. And then a ray that is, if it's going through the center, it doesn't get bent at all. And then a ray that is traveling through the focal point on the same side as the object will get bent parallel to the axis. So these are kind of weird to think about or kind of just read here. So let's go through an example. So as an example here, I'm going to draw an image on the right-hand side, or on the left-hand side here. So we're going to do it as an arrow. Arrows are pretty common for doing ray diagrams. So I've got this arrow, and then let's actually make that a green arrow. So it's easier to see the difference between what I'm drawing and what the object is. All right, so now we've got to draw a bunch of rays, and it's going to be a little bit tricky for me to do this cleanly on the computer, but if you want extra support or help or it's not clear what's going on, we can definitely talk about it in person. So I always start by drawing my parallel to the axis of the lens. So this is parallel to that, see that white line below. Once it hits the lens, we don't worry about the shape of the lens here, we just worry about a line straight through the middle. Then it's going to get bent to go through the focal point, and that's what I've got labeled in red here as the 2 focal points on either side of the lens. So that's not bad. And it just keeps going on forever. So light that comes from the top of the arrow going at this direction will hit the lens, get bent, and then travel in that direction straight. Next, we need to draw a line straight through the center of the lens, so through this point right here. And light that goes through the center of the lens, that's pretty poor, so let's try redrawing that. You're going to definitely benefit from using a ruler if you're trying to do these really precisely. If we're just sketching, we can generally get away with it, but if you're wanting to do something precise, you're definitely going to need a ruler. But that's not bad. And that keeps going straight curved there a bit at the end, but we'll fix that if need be. So that one goes kind of straight through. If we want, it should probably be more like that. And then finally, we'll draw one through the focal point on the same side. And then when that one hits the lens, then it's going to go in a straight line. And so straight line or parallel to the axis is a little bit easier to draw because I've got grids here. And yeah, that's a nice diagram here. So we're ignoring this top line here because that's where it curved. We have the line that's going parallel to the axis that then gets bent through the focal point. We have the line through the center of the lens, and then we have the line that is through the focal point on the same side that goes parallel to the axis again. And that means that we see they rejoin together at this point here. So I'm drawing a yellow arrow to indicate where they're rejoining. That's not the image. And that means that the top of our arrow should be recreated right here. Then we could do the same idea of going down farther and farther, and you can test this on your own if you wish, or you can take my word for it. But it basically creates an image like so. And so in this case, we get an inverted image on the other side. And like I said, you can test this by going through. The easiest example to see is if we went from the center. Well, from the center, all of our lines have to just go straight through the middle, and then they end up over here. So we know the bottom has to be at the bottom, the top has to be here, so the only way for that to work is to get this shape. Then we could talk about describing this. This is a real image because the lines come back together. It is an image that is probably farther from the focal point. If we count up these boxes, it looks like it's farther. It is magnified, it is larger, and it's inverted. It's upside down on the other side. So that's one example. Let's do a second example. This time I will put it closer to the lens, so inside the focal point, so we can see a couple things there. So this one may not be perfect, but we'll see what we get. So again, start with parallel to the axis, and then that's going to go through the focal point on this side. Then we're going to draw a line through the center. Something like that. Then we have to draw a line through the focal point. But there's no lines from the top of this arrow that go through the focal point, so instead we pretend as if it came from the focal point. That's really bad, so let's erase that and try again. Again, these are a lot easier with a ruler. I just don't have one on the computer here in PowerPoint. That's looking better. Now at this point it does connect, so we're going to continue it on. And then this is going to go parallel. Like so. And what we notice is these lines don't intersect. They don't come back together. So that presents a little bit of a problem for us because we don't know what happened, like what's going on with the image. So instead what we do is we go backwards and say, well, if my eye was over here, so I got a little eye here, what would I see? Well, all these lights would be hitting my eye, and my eye would assume that they started in the same place. So if we work backwards, this one should, again, our eye assumes it was traveling in a straight line. This one working backwards, our eye assumes straight line. This one working backwards, our eye assumes a straight line. And you'll notice they do, those like assumption lines do intersect at a point. So in that case, the image that is created would be right here. So it creates an image in this case, it's a virtual image. It's on the same side. Well, let's start with the easy one. It's on the same side as the object, right? The object is here. The image is here. So it's easy to see it's on the same side. It's easy to see it's farther away from the lens. It's easy to see that it's bigger than the lens. And it's easy to see that it's upright. Those are nice and easy. How do we know it's a virtual image? We know it's a virtual image because we had to look from the opposite side and pretend that all of these lines had come from one point. So if the lines don't come back together, they don't re-intersect, then it's a virtual image. And it's a virtual image because our brain thinks that they all came from one spot, or a camera sensor thinks that they all came from one spot, and that spot is where the virtual image is located. So if you put your hand back here and tried to touch the image, nothing would happen. It wouldn't move or distort or anything like that. You would just be swiping at nothing. Whereas previously, if you put your hand right here, so if, your hand was in the place of where that image is, you would distort it, the image would be hitting your hand, you'd see an arrow on your hand, etc. So that's what we have for ray diagrams on convex lenses, lenses that focus the light inwards.